Okay, let's take a look then here at example number 2. This is the last one that we'll do together, and then examples number 3 and 4 are ones that you would have normally had time to work on during class, so that way you could have practiced. Okay? There are, again, a bunch of problems in the worksheets that you can begin to practice with as well. But let's take a look at this one first here together. An industrial company claims that the mean pH level of the water in a nearby river is 6.8. You randomly select 19 water samples and measure the pH level of each. The sample mean standard deviation are 6.7, that's for the mean, and 0.24. That's what it means by respectively. They come in the same order. Is there enough evidence to reject the company's claim? To reject what the company says at a 5% level of significance, assume the pH levels are normally distributed. Okay, again, same basic idea. It seems like I would know exactly what side of the formula sheet I'm working with because this is a problem that's asking about averages. So I'm going to do stuff over in this box as opposed to stuff with percentages, which meant I would have worked with the left box. So I'm going to go ahead and start to set up my hypotheses. I can see that I'm going to be asking something about averages. So let's see. What does the company claim? The company claims that the mean pH level in the water is exactly 6.8. Okay, perfect. So that's easy. Their claim is H0. You randomly select blah, 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 all this stuff. Part A, is there enough evidence to reject what the company says? Could you reach the conclusion, no, the company is wrong? Well, you could think about what would that mean when I write that as a hypothesis down here in H1. Would that be greater than? Would that be less than? Would that be not equal to? Notice that determining that has nothing to do with the numbers that I was given. It's got nothing to do with the X bar, nothing to do with the S, nothing to do with the N. It has only to do with the question. Is there enough evidence to reject the claim? Well, rejecting what they would say would be a not equal. And remember that every time we see a not equal, what kind of test do we have? It's a two-tailed test. All right, no big deal. Most of the stuff here is identical. Let's see, evidence. I'll start this time with N. How many water samples did we take? I think it was 19. X bar was 6.7, and my standard deviation was 0.24. I'm going to go ahead and do my checks. Notice my N this time is not big enough to be able to go ahead and actually meet the first check of N being greater than or equal to 30. But I am able to use that second check. And that second check is met because we know that pH levels are normally distributed. The problem gave that to us. So that means X bar has a T distribution. Again, if you forget that it's supposed to have a T distribution, that's the whole point of the formula sheet, having a T on it, so that you never forget that. Okay. The last thing that I can be ready to do is to write down my T-score. All right, I'm going to go ahead though down here and draw my picture. There are a lot of X bars. I want to see if I have a weird one. My X bars line up in a T distribution, which strangely looks like a normal distribution. The average, well, if we're believing that H0 is true, the average should be 6.8. But we found an X bar of 6.7, so that's a little below average. Since it's a two-tailed test, remember that we have to shade kind of like an equal portion on the upper end. I don't need to find what value occurs there. That's not important. I'll just find the corresponding t-scores and get ready to set up what my p-value is going to be equal to. Remember, my p-value looks like it's going to be double the probability. And it seems like it's going to be easier right now to find the area in the bottom tail because that's where I have numbers. I would need to have an X bar that is less than 6.7. I'll leave it to the calculator to crunch out the specifics of what that number actually is. So again, I'm going to go to the calculator and try to crunch this out. I'm going to do a t-test. This time my average is 6.8. This time I got 6.7. My S value was 0.24. My sample was 19. I had a not equal to this time. And if I go to calculate, here are all of my numbers. My t-score is negative 1.8162. My p-value is 0.0860. I have to keep in mind, though, what's my value of alpha here, my level of significance? And I think if I scroll back up, I could determine that that's supposed to be 5%. So, did I get an X bar that's considered rare or not rare? Well, in this case, seems not rare. So, in my conclusion, I would state that I do not reject H naught. Or again, another way to say it would be that I stick with H naught. I'm going to write my conclusion in the two sentence format that we've been doing this entire time. So I'll say, it is not rare to get a sample average of 6.7 by chance if the real average is 6.8. Okay, so then I can go ahead and say, therefore, we have no reason to doubt the average pH level is 6.8. I don't have any reason to doubt that. I could also say, I didn't find any evidence to doubt that. I didn't find any evidence to believe that it would be something different. Boom. Essentially, I think I'm going to go with the company's claim here. No reason to disbelieve them yet. Although it's just a guess, so we may have made an error. In this problem, if we were sticking with H0 and we might have made an error, we might have made a type 2 error. Okay. Again, these ideas take some practice, but hopefully if you compare what we did last section to this section, you'll see that for the most part, everything that we did was kind of the same. We just had some slight modifications with dealing with averages versus percentages. All right, that concludes this video. In the next video, we'll be going ahead and it'll be content that we'll be covering after spring break. We'll get into concepts of confidence intervals and the rest of the front side and back side of the formula sheet. Please, again, be aware that there are lots of worksheet questions you can try to practice with, and I would highly encourage you to start practicing with those. I'm going to try to have spring break videos up before the end of break, so if you'd like to work ahead of schedule, you can feel free to do that. Okay, if you got questions, please by all means let me know and come see me in office hours.